We are going to take one very significant topic, which is deduction of Ohm's law. We know Ohm's law is V is equal to IR. How we can relate it with resistivity and other factors? Let us see. For this, deduction of Ohm's law, right? This is electricity. Since we know we have a relation, and relation is I is equal to NEAVD. From where we do this, we can see that we define I as charge per unit time. Charge can be NE and time can be distance. The distance is length of conductor, and this speed can be VD. VD is drift velocity. Plus Q and E is for limited number of charges. Since charge in this case is infinite almost, so we multiply it by its volume. So it becomes A into L, area of cross section of conductor and length of conductor. So L and L gone. Therefore, we have this relation I is NEAVD, right? Then in this, we have also done VD, which is for the drift velocity. Drift velocity, basically the velocity acquired by electrons against the direction of applied electric field. So we use first equation of motion, V is U plus AT like, and then we do Vd remains Vd. We take U as 0 and acceleration. Acceleration generally we write force by m, मैकेनिक्स में हम लिखते हैं, और F को हम कन्वर्ट कर देते हैं इलेक्ट्रिक फोर्स में. So F can be QE, and thus A becomes QE divided by M, और T को लिखते हैं tau. Therefore, we get a formula Vd as QE upon M into tau. Tau को बोलते हैं average relaxation time, the time between two successive collisions of electrons. Time between two successive collisions of electron is called relaxation time, tau. Now, let's write it like NEA, and in place of Vd, we'll write in place of Q, let us take electron E, and this is also capital E is electric field M, and this multiplied by tau. We also know a relation, which is electric field is V upon L, or distance D. So if we convert V by L, then it becomes N E square A. Now V divided by ML, and this tau remains as it is. So we have now this V for potential difference, and in LHS we have I for current. So we write like V upon I, and it will be ML upon ML divided by n e square a tau. And V upon base R, basically we write R from Ohm's law, and R we write rho L upon A. So if we look into it, what we can do, this L and A gone, and therefore we are left with rho is equal to M upon n e squared tau. So up to this is deduction of Ohm's law, and when we equate formula for R, then we get rho resistivity as M upon n e squared tau. In this, length of the conductor missing, cross-sectional area missing, and this is the reason we say that the rho does not depend on length and area, does not depend on length of conductor and cross-sectional area of conductor. So this is very significant. You get 3 marks direct question in NCERT also. And in this we have done two small concepts also, which is one is relation between electric current and drift velocity, and drift velocity formula also Vd is QE upon m. This Q can be replaced by electron, small e, capital E divided by m into tau. So one of the important concept, and then we can do the heating effect of current. When we talk about heating effect, it is all about heating element. Heating element, like now winter has begun. So in winter we are using geyser. That is heating element. What it does, when we switch it on, water is heated. So getting heated means because inside that element heat is produced. And so this is about heating effect. So if you see heating effect of current, right? For this we can have an arrangement. An arrangement is let us take a resistor R, and it has current for certain time t, which means from Ohm's law, how much work is done to transfer this current in certain time t. It means the work done is, we write V into Q. V for voltage, potential difference, and V from Ohm's law, we write IR. So IR, and Q from Ohm's law, like I is Q upon T, Q can be I into T. So Q is I into T, and thus it becomes I into I square. So I square RT. This amount of work done is actually stored in the form of heat. For that we use Q sign. So Q becomes I square RT. Obviously heat is measured in joule. Now when we talk about a device having some electric power, the power we write work done upon time. So work done can be I square RT upon T. So T and T cancel. Thus we get I square R. So this is one formula for power in terms of current and resistance. Also we know I can be V upon R, and so power can be V square upon R square into R, which means V square by R. So second formula. And then the same we can write R as V upon I. So power can be I square into V upon I. So In square gone, so Vi. Thus we get three formulae for power. All are manipulated formula, derived formula. Original remains same. Power is work done upon time. And if you want to calculate the electrical energy consumed, so this electrical energy consumed E would be power into time. Power we take 1000 watt and time we take 1 hour. So 1 hour gets converted into second. So 1000 into 60, which becomes 3.6 into 10 raised to the power 6 joules. This is also known as kWh, kilowatt hour, right? Kilowatt hour. So 1 kilowatt hour is equal to 3.6 into 10 raised to the power 6 joules. And in domestic consumption, that we get electricity bill. In that bill, it is calculated as unit. So unit means basically kWh. So when we talk about this 1 kWh, which is commercially known as unit, UNIT, it means numerically same 3.6 10 raised to the power 6 joules, right? Thank you so much.